Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 3 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Thanks to all of our participants and subscribers. I'm trying to share. You'll notice the big blue line there on the top. Over 85% of our viewers have not subscribed, though. If you watch 2 or more episodes, please consider subscribing.
We've got a little bit of cybersecurity news.
Sorry.
Not much. Yep, that is me. It's what we call Patch Tuesday, which is the second Tuesday of the month, where Microsoft comes out with all of its updates. At least all of the planned updates. You'll occasionally get updates in between, either virus definitions or oops, we screwed up. But most of the updates come the second Tuesday of the month. So if you haven't rebooted your Windows machine, go for it now.
And most of them are security issues, so you really want to do that.
Yeah.
I see we got a comment on.
Yeah. Also, Macs have had updates, not on Tuesday, but within the last couple of weeks. So if you haven't updated your Apple product, whether it's a fruit phone or a computer, you can you should do that.
Hey, Scott.
Yeah.
Oh, it's a very interesting topic too.
Yeah, it's really hard finding actual technical details. I found a technical article, but it wasn't very technical, but it's more technical than the rest. So,
and we got some basic stuff too to help out. So anyway, that brings us to tonight's episode. It is a crunchy topic on blockchain. We'll be back in 8.3 seconds. There's a link to that in the description. Several sources explain blockchain something like this. It is a distributed database or ledger shared across a computer network's nodes in a way that is transparent, immutable, and resistant to tampering. Each block contains data, and the blocks are linked in a chronological chain. They are best known for their crucial role in cryptocurrency systems. That's where really we know about them. Maintaining a secure and decentralized record of transactions, but they are not limited to cryptocurrency uses. Blockchains can be used to make data in any industry immutable, meaning it cannot be altered. Of course, garbage in, garbage out, but we'll come to that eventually.
And immutable for certain definitions of the word immutable.
Are you ready to share?
Yeah, let's share my screen.
Alrighty, there you go.
Here's what is a blockchain. Oh, scroll up on yours. I want to see the top of the paragraph that you read off.
Oh, sure.
Okay, so everything that Pam read is essentially true. It's a distributed database or ledger shared across computers, networks, nodes. Now, let's get into some definition. And this has, this is TechTarget. It has a really good explanation about blockchain. Unfortunately, it has this thing in the top of it that just will not go away.
Yeah.
It does download a guide that is actually a very good guide. So I'll give you both of these links when we're done here.
Great.
But so let's just get some stuff out of the way. Distributed database or ledger. What does that mean? It means it's not in rows or columns. It's just data stored in blocks. And we'll get into that later, but
yeah, I have a couple of really short videos that are pretty good explaining it, I think.
Yeah. Now, you know what? Now, what is a node? A node is any computer basically attached to that system. Now, there's 3 types of nodes. And this is specifically for Bitcoin, but the others are similar. You have a full node, which has the entire blockchain, every single block. And for hey, Cliff.
Hi, Cliff. Welcome, and sorry about the rain. He said that was clear for a little bit anyway.
Oh, well, that's nice. But,
He saw
so,
Space Station.
okay, so nodes can be full nodes, which contain everything that is current.
Okay.
From what they call the Genesis block, the first block.
Mm.
And those are typically about 50 gigabytes of information, and take that more or less with the different blockchain
That
types.
seems like a lot. 50 gig.
Oh yeah, it is.
Okay.
Back in the 2000s, like probably 2010-ish. No, 8, between 9 and 10, I think.
Okay.
I got into it sort of, and I had downloaded the entire block. Now, internet speeds were pretty bad back then, and it took me 7 days to download the block. And it's only grown since then. I mean, grown a lot since then. So
yeah, you're looking at Bitcoin, right?
Right, because it's what was there at the time.
Right.
So a full node has everything. A light node, it's just some of the most recent ones. And most people who are signed into Bitcoin, they have a light node. They've downloaded a few blocks, and if someone asks for it, they your computer feeds it up. And then there are mining nodes, more or less used. Bitcoin, you know what Bitcoin miners are. You've heard. They put a bunch of transactions together into a block. And the first person, that's interesting. The first person who finishes it gets the Bitcoins for creating that block. So it's a race.
So they really gamified it, sounds like.
Right. Now, most of them, and I think Bitcoin has changed to the point where it creates a block every 10 minutes, and of the people who've completed it, it gives it to one of those people. So it basically, and usually the one who completed it first, but not necessarily. So every 10 minutes, it gives out Bitcoins.
Wow.
Now, every 4 years, the Bitcoins that it gives out for completed block halves. And Bitcoin is made so that there is a maximum number of blocks. But like Ethereum does not have a maximum number. In fact, already has more blocks than Bitcoin does. Because it's also a lighter system, so it makes the blocks faster. But so that is nodes and what a distributed network, because any computer that has any of the blocks is a backup for everyone else. And anything that has all of the blocks, like most financial houses and stuff, have the entire set of blocks, because they want to make sure that they don't have to wait for the information that's already stored there. And so it makes it very resilient, kind of like the way the internet is resilient, in that if there's a problem somewhere, everything just routes around it. They would have to take out an awful lot of computers to basically disrupt a blockchain.
Oh, okay.
Also, it makes it so that it's hard to tamper with.
Or it's very evident that it's been tampered with.
Right, because if blocks in a node have been tampered with, for one thing, they cryptographically sign the blocks so that it's easy to detect that they've been tampered with. But even if you manage to, unless you can tamper with 51% of the blocks, that block out there, 51% of the copies of that block, you'll basically be deleted. The tampered blocks just get deleted. So,
do we know how many get?
No.
Do we know how? Okay.
No.
So there's some number of duplicates out there, which makes it you can.
Well,
check it.
There's at least for every financial institution that has Bitcoin, probably has a full node. So there's at least that many duplicates.
Okay, the 50.
Yeah, 50.
Okay.
Yeah.
Wow.
So
like it might be a lot.
So it's very robust. So the blocks contain data and are linked in a chronological chain, because it uses the hash for the previous block to encrypt the next block.
Hash being like a code, or
Yeah, it basically is like,
I read about it, I forget.
yeah, this set of letters that repeats a lot becomes this number. And it just does that until it encodes the whole thing.
Okay.
And there are different ways of doing that. This uses a Merkle tree. If you want to look up Merkle tree, you know, you can find it in the wiki about blockchain. I don't actually have the wiki up because I was looking for other things, but the wiki is a good read for it. And you can find the Merkle tree in there with an actual link. I've seen the Merkle tree in some of these, but there aren't necessarily links. But if you care about the details of how it's encrypted. So it's basically chronological because the encryption key is essentially the hash from the previous block. So you can always trace them. And
I think they're timestamped too, right?
yes. But, you know, that's
I've
less.
read a little bit about this. I haven't read as much as Jeff has.
Yeah, that's, oh, Janie.
Oh, it's Happy Ice Cream Day. Hi, Janie. Welcome.
Oh, yeah. Speaking of which, it's my lucky day. Friday the 13th. I figure so many people want to be unlucky on that day that someone has to take the luck. So hey, I can do it. You know,
this is my life.
So, you know, so it's very hard to alter the blocks. Okay. You know, because one, they're encrypted and the hash is already baked in. And if you alter a block, then it can't decrypt the next one. You know, so it kind of flags itself. But also, if it doesn't agree with, like one block doesn't agree with 50 blocks, well, that one block gets booted. Yeah. Now,
sort of a self-healing.
Right. Yeah. They are best known for their crucial role in cryptocurrency systems. Yes. I would argue that they're almost exclusively used for cryptocurrency.
So far.
Yeah. Now, I see a lot of use cases of it could do this, it could do that, it could
sort of a solution looking for a problem.
Yeah, exactly. Yeah, it could
that's common. I mean, the laser was like that for a long time. And
right. Now,
I'm sure other things too.
Now, one thing that I have seen it actually used for is smart contracts. And that's a contract that you basically set a bunch of conditions, and every step in the way basically reports its conditions. You know, so when product X gets picked up, maybe a micropayment goes to someone. When it gets delivered, you know, maybe the micropayment goes to the carrier. You know, and all of this is defined in the rules, and it's all automatic, no billing, no nothing. It just takes care of itself. One of the things that it says transparency, and that's because anyone can pretty much decrypt it in a public blockchain. There's private blockchains also, but we're dealing with a public blockchain. Now, they also say that it's good for personal information and medical records, where you always have access to your own medical records. Here's the thing. Yeah, it's a blockchain. So does everyone else. So, yeah.
Not sure you want that.
And not only that, but the big medical and insurance companies like sitting on your data. They don't want to give it up. So you're going to pull your own medical records out of their cold dead hands, essentially. So I don't
crazy to me, but
yeah, I don't see that happening. It probably will eventually, but eventually the sun will supernova us, or you know, so you know,
not our sun, but
no,
so
it'll go poof.
So I could see if it were in private hands, it might be useful to you.
Well, that's just
in private.
There are basically two types of blockchain, but they count four of them, and because there are some variants. There's a public blockchain, which is what you're used to with Bitcoin, Ethereum, which is the other big blockchain out there. And there's private, and basically anyone can be on it. There's no controls as to who can be on it. Anyone can produce Bitcoin. Anyone can buy Bitcoins. And by the way, the Bitcoin blockchain is set up so that you can pretty much only move Bitcoins around. It just maintains the transactions. Ethereum was built, it's a lot more robust. You can actually do other things with it, store other data. So all of these other use cases that I talked about, pretty much all use Ethereum, whether they're public or private.
Well, Bitcoin was floated out of there as a test bed for.
Yes.
It just happened to make some people some money too. So.
Yeah. So a private blockchain is basically owned by a company. IBM has one. There are some others that, your company, maybe medical institutions will have private blockchains for medical information. Yeah. Which means that only people that they permit can actually see the data. Far out. Yeah. So, but public ones are much more robust in that it's really hard to spoof the data. It's really hard to alter the data. A private one, well, it's all in one spot, owned by one company, and they could go to the work of altering enough blocks to actually change the data. So they say that public chains are more secure, but they don't mean your data is secure. They mean that it can't be altered. It's actually the public ones are the worst for privacy, but they're the best
because of transparency.
Right, because of transparency, but privacy.
And that's one of the weird things about all this. The more I've read, the more I get like, why are they using this term for this? It just sort of seems like it means something else.
Yeah, one of the things that you'll see in a lot of these, and it's one that, trustless. What it means is that not that it can't be trusted. It means that it doesn't have to trust. So a block for a blockchain can be anywhere. It doesn't have to have a password on the computer. It can be in a 14-year-old's computer because it's hard to alter. And if it does get altered, the system will figure it out.
But if anybody can alter it, a 14-year-old could figure it out.
They'd have to alter 51% of the blocks.
Right.
You see, that's the...
Wherever they are. And they
exactly.
They can be all kinds of places. Do you want me to run those videos? Those are those are real nice primers, I think. And let me go ahead and tell you where I found this. I'm going to actually bigify this.
And while she's doing that, I'm going to put a couple of these links.
So this is on IBM.com. It's kind of got some basic stuff. What is a blockchain? And of course, you can read these. I'll share this link as well after I find the videos for you. And why it's important. Key elements of, and Jeff's covered a bunch of this stuff, how it works. What I really want to get down to are these videos. Yeah, see, it's trustless, but greater trust. So I wish they would pick some better terms for some of these.
It is a computer security term.
I see. Okay. So if you're not in that business, you may not know. Yeah. So here are the videos. There's 4 altogether. I'm going to run these first 2 for you. They're very short, as you can see, about a minute and a half each. And these other ones are short too. But yeah, I thought it was a really great place to start. And it gave me at least an understanding better for some of these terms. So here we go. I'll just play it.
Blockchain. Confusing. Even confounding. You have a block, then another block. And those blocks contain information. It could be any information, as many blocks as needed. Each one chronologically connecting the blocks behind and in front of it. And when new information is added, any information, a new block is added. If previous information or data is amended or changed, you guessed it, a new block is added. The information in those blocks is secure because a blockchain is a digital ledger system stored across a variety of networks. A system that can be programmed to record and track anything of value, from medical records to food supply chain transactions. Most people think cryptocurrency like Bitcoin is the same thing as blockchain, but blockchain is not Bitcoin. Blockchain is the underlying technology that enables Bitcoin, like how an engine can power a tractor or a cargo ship. Let's look at what blockchain can do.
And I don't actually think he answers that question.
Yeah.
You know, what can it do in part 2? But I did think part 2 had some value, so I'll go ahead and play that for you as well.
And there's more parts than just those two.
There's 4 altogether, yeah. But I thought these were really important and interesting to hear. As kind of a foundational primer kind of information.
The way that a blockchain tracks and stores data is revolutionary. But this new technology is actually based on the centuries-old method of recording information in a ledger. Unlike a written ledger, or even a file stored on a computer, blockchains were developed to be decentralized and stored across multiple computers. Data is synchronized across a variety of locations and is tamper-resistant, which creates the most important function of a blockchain: trust in the data. Picture a spreadsheet that is duplicated multiple times across a network of computers. Then imagine that this network is designed to update that spreadsheet anytime a change is made to it. So who has access to your data on a blockchain? IBM Food Trust uses a permissioned blockchain, which means that the identities of anyone on the network are known. Participants also determine what data is seen by whom. With blockchain technology, we're headed towards a new reality of transactions with trust, accountability, and transparency at their core. Now let's talk about how this technology is going to transform the food industry.
And they've got their own, you know, axe to grind. But
Yeah.
the idea behind it is to understand that this is basically these ledgers. They get updated every single time. And so many of them do that it's very, very hard to mess with it.
Right. And IBM is an example of a private blockchain.
Yeah, okay.
And that's...
So I'll go ahead and grab this link for you as well.
Yep.
And add that to the comments.
And let's
Should be a clickable link for you.
Let's put mine back up for now, because I want to show you
Sure.
something. Okay, so this link here that won't go away, download this guide. This drives me nutsos, but I don't know,
even after you download it, it doesn't go away.
Short trip, but yes. Yeah, it just basically expands on what I've said so far. So if you're really interested, this is a good read. It's a good top level of what blockchain is.
Good.
Now this is the guide itself, and here's where blockchain use cases in real world industries. Supply chain. Now here's where they say it could be used for this. Now Walmart Canada actually uses blockchain in supply chain, in their supply chain. So Walmart Canada is actually testing this out. I don't know if anyone else who is using this. So this is again a source of a case of, well, it could be used for this if anyone wanted to. Banking and finance. It's currently actually used in by some banks. MasterCard and Visa are testing it. Cryptocurrency, of course, is the main thing, but there are some, but it hasn't really gone into financial service providers, credit, insurance, banking, and investments. It hasn't really been used for that yet.
Well, it might change next year. We've been hearing some things about that. So.
Yeah, but using smart contracts, individuals may let each other. So smart contracts is actually something that's currently ongoing. So that's in use. So Bitcoins and cryptocurrency and smart contracts are pretty much in use. Healthcare, again, you can use it, but I don't see that happening anytime soon. Especially with how leery people are of getting healthcare information out there. I mean, so many countries have very high, very stiff penalties for making information accidentally available or purposely available to anyone but the patient and their provider. Government. Oh yeah, because no one could do it better. Vote online. Okay, I don't have the article here, but I just want to say no, because a number of countries have it set up so that your votes are, your voting is private. It's, you vote in secret so that no one knows how you voted. Well, the thing with a vote blockchain
Transparent.
it's transparent, which means that everyone knows how you voted, which means that, yes, maybe you get services or denied services based on how you voted.
Yeah, now see, I think in our case, of course, it's Congress and Senate. We should know what they're voting, and we do. We
Right.
can see how they vote, but this would make it a lot easier.
But we can't always see how they vote.
Oh, we can't? I thought we could.
Because only if they do a roll call. If they do a simple yay or nay, then whichever side is loudest wins. And that's how a lot of votes are, so that you can't tie a specific person to a specific vote.
I thought there was a list somewhere for
Yeah.
everything that got voted on.
There is, but they
Anyway.
usually just say, which one. Now, if they do a roll call, then you know how many.
Yeah, we could take that offline. But
Yeah.
to me, a person, an individual person's particular vote, like for an election, I think should be private.
You're right. Yeah. So public, blockchain, private blockchain, hybrid blockchain is, some portions are private, some portions are public. This would make it so that you could see most information, but the personal information like your address, your social security number can only be seen by people who theoretically are allowed to see it. But, but that's just more complicated. So
sounds like it'd be like testing putting your test scores up on the wall, and everybody knows it by their social security number, so there's no names attached.
Well,
to it.
no, that's what Cal State Fullerton did, and found out that yes, they're posting everyone's social security number.
Yay!
So then because Cal State Fullerton was using social security number as their student ID.
Well, like in Arizona, that was also.
So they gave them a separate student ID so that people who were scammers couldn't grab the social.
Yeah, social security number is kind of a big deal here, and I think it was on my driver's license in Arizona. So yeah, same sort of deal.
Yeah. Now consortium is kind of like a private blockchain, except that it's not controlled by one entity, but by a group of entities.
Okay.
So it's kind of the worst of both worlds.
Okay.
But so this is the guide. It has 4 main types. It basically goes into a lot more detail than the.
Is that a different page on that same site?
Yeah, this is the thing that you download.
Okay. Oh, I see.
So I did give a direct link to this.
Okay.
I think they're both useful. Now, trying to find out how Bitcoin actually works, or how blockchains actually work. I looked at how Bitcoin's fundamental technical structure.
Cool.
Because it uses blockchain. So, and I will put this in the notes too. So here, a blockchain ledger, we've talked about that. Peer-to-peer network nodes, we've talked about that. Proof of work mining and Bitcoin's consensus mechanism. We talked about that. They go into a bit more detail than I did. So that's good. Anatomy of a block. They actually show what makes up a block.
Cool.
They don't do a very good job of that.
Oh.
But it's more information than you have anywhere else.
Okay.
I would have liked to have seen this number of bits is this number of bits is this, but they don't do that. Bitcoin halving. This is where almost all cryptocurrencies that you mine every 4 years, the value that you get for mining a block halves.
Half of what it was the previous 4 years.
And
okay.
Bitcoin forks. This is any of them. And that's where they have to make a change. Maybe they make a change in the underlying software that runs it, and it's no longer backward compatible. So they fork it. So you've still got the old unaltered blocks, but then you've got the new ones that have been updated to the new system. So that's a hard fork. And that's basically where you end up with 2 blockchains now. A light fork is one that is essentially self-healing. They make a fork and you and then eventually it remerges. Once updates happen, enough updates happen.
Would it be helpful to show that diagram isn't that the Merkle stuff or no?
Oh, the Merkle?
Because I have it right here.
Yeah, go ahead and show the Merkle.
Okay, switch to because I do have the Wikipedia, because I'm trying to get basic information, and so of course you can read this, it'll be easy enough. But the thing he's talking about here is this Merkle diagram.
There was a link to it right up there, but do they have a?
Yeah, they got a picture right here. So these forks are what you're talking about, right?
Yes, those are forks.
And I guess in some cases they die off because
they're no longer used. Yes.
Right.
But they could, if enough people liked the old way of doing it, have two different ones going.
And they have it here. The main chain black consists of the longest series of blocks from the genesis. I guess that's the green one.
Mm-hmm.
Way up green to the current block. Orphan blocks, purple, exist outside of the main chain. So here's the original one and all the ones that follow, and these got orphaned for some reason.
Yeah, there was a fork where they changed the technology slightly. And so the ones that don't follow the main line, the one that gets adopted ends up being the main line. I mean, if they don't like the change, they won't do it, and that will die off. But if they do like the change, then that one will grow, and the other one will be abandoned.
Okay.
So,
all right, I'll grab that link for everybody too.
And yeah, and if you want to show the Merkle tree.
Yeah, isn't that what that is?
No.
Oh, it's not. I thought that was the Merkle tree.
No, that's just the forks. Go to up. There's a Merkle tree. They talk about the Merkle tree.
You want to share?
Okay.
Because nobody can see this.
No, there, right there.
Oh.
That's
the Merkle tree. That's right.
And that's a way.
It looks like an org chart to me. So.
Well, it's a cryptographic thing of if it's this, go here. If it's if it's something else, and it's a way of quickly encrypting something or producing a hash.
Sounds like more like a flow chart to me. If then and
right, but it's a quick way of encoding something.
Okay.
So it's just a very fast encoding method.
Okay.
So that's all.
All right.
So I'm gonna grab mine again.
All right.
And so Bitcoin halving. This is in 2009 to 2012. Creating a block for it was 50 bitcoins. You'd get 50 bitcoins for mining a block. 12 to 16, 25 bitcoins. 16 to 20, 12 and a half. 20 to 24, 6 and a quarter. Now, it did occur in 2024. 3 1/8 Bitcoin now for mining a block. And since everyone has such high equipment, your chances of actually winning, the race to create the block is very, very small. And the cost of electricity is up. So the money that you get is down. The cost of electricity is up. It just does not make financial sense anymore in a lot of areas. You have to have really cheap power to do this. I mean, I know someone who mined like 12 bitcoins.
Oh, wow.
I think he had more at one point, but he was spending $20,000.
Oh, jeez.
In electricity and making $30,000 in Bitcoin.
Not terrible, but
that's an awful lot of electricity.
Probably better ways to.
Yeah, that was an awful lot of one computer hardware plus supporting that electric bill.
Yeah.
So, and now it's much worse. Now you're getting a quarter of what it is, and electricity prices are higher. So, and everyone else is faster too. So unless you shell out like $100,000 for a rig, you're not getting any.
So the returns aren't great.
You're spinning your wheels and not getting anything.
Okay.
So Bitcoin forks, they talk about this some more.
Wait, let me share again.
It's just so that's how Bitcoin works. This one is how Ethereum works. Now it's not as technical. It's not as good as the Bitcoin one, but it does show some of the differences between the Ethereum way of doing it and the Bitcoin way of doing it.
Cool.
So I will put both of these in in the chat so that you can see that. think that's it for me for now.
Okay.
If you guys have any questions, let me know, because I do know a bit more than I actually said, but
That's typical.
kind of was hitting the highlights of it to let you know the basics of it. And if you want to dig, I'm going to be posting up a couple things that you can use for really
Okay.
good digging.
I don't see the share, the one you just picked.
Oh, I know I haven't.
Okay. All right.
I was busy talking.
Some stellar events this week. We're talking about December 13th through December 20th. December 13th, that is tonight. Uranus and the moon are in conjunction. And the Pleiades is 0.1 degrees south of the moon. There is an occultation. We don't know where. Sometimes the calendar tells us, and sometimes it doesn't. Also, there's a meteor shower going on tonight. It's the Geminids. These range from December 4th to December 17th. The peak is around, like I said, tonight into tomorrow. All night, unfortunately, we got a big moon. It's like going to be full soon. These will occur all night. They can be from anywhere, but they generally seem to radiate from Gemini. And this is actually pretty frequent, 75 to 120 per hour. This is from the comet 3200 Phaethon. Phaethon. We never did figure out how to pronounce it.
Yeah, Phaethon.
Yeah, it's Phaethon. Like I said, the moon is 12 days old. It's almost full. It's going to interfere with this meteor shower. According to the calendar, it was like look east in the early morning after moonset, I guess, but it's going to be up there most of the night. December 14th, Jupiter and the moon are in conjunction. Jupiter is 5.5 degrees south of the moon. December 15th is the full cold moon. The moon runs high as well. And Mercury is stationary, but it appears stationary from our location. December 17th, Pollux is 2 degrees north of the moon. December 18th, Mars and the moon are in conjunction. Mars is actually 0.9 degrees south of the moon. There is an occultation visible from, this one told us, northern Alaska and northern Canada. December 19th, Regulus.
So Rodine, head north.
Yeah. Regulus is
Lots.
December 19th, Regulus is 2.5 degrees south of the moon. And December 20th is back to the Friday night show. I'm going to do another profile. Stick around to find out who. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week?
If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, December 20th, where Pam will profile Hal Walker. He's local to us, maybe not to you guys, but he's local to us. And he was the first person to shoot lasers at the moon to help us determine how far away it is from Earth. And that's how we found out that the moon is slowly drifting away from us. Hal is an interesting person and part of our local organizations.
And unfortunately, I just got an email from one of our local guys too. Seth Potter's last name.
Yeah.
Because Hal just died recently, so I thought, oh, he sounds really interesting. I didn't know about the laser thing. I don't remember meeting him, but maybe. So yeah, I think he was part of the Oasis group, which is a National Space Society chapter out here in the Los Angeles area. So I'm going to do some more digging, find out some more, because, yeah, shooting lasers at the moon.
Mm-hmm.
How cool is that?
It sounds like an episode from The Tick.
Oh, boy.
A villain carved his initials in the moon.
You going to dress up blue? Okay, anything else from you?
Nope, that'll do it.
Thank you, folks, for being here. And we saw Janie, and we saw Cliff and Scott. Thank you so much. It's always a better show when you're here and you help us out and leave us comments, that kind of thing. But have a great week. We'll see you next Friday. Good night.
Good night.